So did you want to introduce me? Or not?
Oh, sorry. Professor Christine Chaille has been, she designed our ECE 314 course. That's the one that facilitating math thinking for young children since 2017, and she's been teaching that course since then, throughout even the COVID period, and we're happy to have her back in Singapore. And I've learned a lot from her because I was also teaching ECE 314 at one time. So
we taught together a lot. Yeah.
Yes, that's right. Maybe I'll leave Christine to introduce and to tell us about where she comes from and her wonderful grandchildren as well. Yeah.
All right. I'm just going to talk about my grandchildren the whole time. No, as Cynthia said, I've been working with SUSS since 2017, and what was fortuitous was that Serene contacted me about this wonderful new program and needed some consulting or advising because she liked my books that I'd written, and it happened that in 2016 I had retired from Portland State University. So when she talked about my helping develop some of them, and she said, I don't suppose you could come teach them, and I said, as a matter of fact, I could, so that started my work. And I've loved the work here. It's been really interesting and fun to come here to Singapore, except for the pandemic when I had to teach, like 100 students on Zoom. It was a nightmare, but also fun in its own way. It kept me busy and connecting with people. So before that, I was at Portland State University since 1991. I was the head of the early childhood graduate program. We have a master's program there, and I transitioned it to a fully online program that's asynchronous, so that people who are enrolled in it now, it's grown quite large, are from like 40 different countries or something amazing, because anyone can take it. So that's sort of cool. And that was a great experience. I also was chair of the Department of Curriculum and Instruction, so covered early childhood through high school, our teacher ed programs. And before that, I was at the University of Oregon for 11 years, where I started a lab school, because my early work was on how to apply Piaget's theory of constructivism to early childhood. And that was my whole goal in life, was to do that. And I actually had studied during my doctorate with Piaget in Geneva when he was alive. I always have to ask, because people say, isn't he dead? Yes, but this was many years ago. So when I got to Oregon, I'd been in Connecticut for 3 years. When I got to Oregon, I realized that I talk about constructivism in early childhood, but nobody could see it in practice at that time in the schools. So in the preschools and early childhood programs, it wasn't very constructivist. There were a little bit, but. So I decided to start my own school. It was called the Early Childhood Center, and it was basically a site for developing constructivist curriculum, and that's what we did with all my master's students, and developed materials and activities and curriculum frameworks for constructivist early childhood. So that was really important to me, to have that ability to sort of give the community something they could see in action. And as a result, a lot of programs, because of all the graduates we had there, became more constructivist, and it was really gratifying to see that. They closed the whole program of teacher ed in '91, which is when I moved up to Portland from Eugene, and have been worked there until I retired, and worked a lot with the Helen Gordon Child Development Center, which is their lab school, a beautiful lab school. And I did a lot of work with them over the years. I still do a little bit, but not so much anymore. And so I've written The Young Child as Scientist was my first book, and then I wrote Constructivism Across the Curriculum, some big ideas as inspiration, which is going beyond science and seeing, putting big ideas into practice across all curriculum areas. So it's an integrated curriculum. So now I'm teaching 300 as well, and that is a funny combination of science, social studies, and integrated curriculum. So I get to put that into a course, which has been fun to do as well. I also had to learn a lot about social studies, which was great for me. But so math and science has been my real focus over the years, and part of it was based on a concern about the way math and science has been taught with young children, very inappropriately in my view, sort of watering down what we do with older kids, which doesn't make any sense developmentally. And so a lot of my focus is on how do you, just like with science, the young child as scientist, how do you acknowledge that young children are teaching mathematics, are thinking mathematically, and their whole world is full of math. And so how do you capitalize on that as a teacher and in an early childhood program without making it boring or rote learning or just transmitting knowledge to children? So what I was a little concerned about what to talk to you about, and I hope it'll be a conversation as well as a presentation, but one of the things I thought, since many of you are working with students in practicum or in coursework, is to try to communicate something about how we, Cynthia and me and Jason and other people teaching 314, consider early childhood math education, and also, since the whole framework is related to constructivist practice, what does that look like? And so I thought it might be helpful to share some of the things that we teach in 314, sort of to give you a little picture of what the students are coming to you with in practicum in particular as they design activities or lessons, and how, what we've tried to communicate and inspire them to do in mathematics. So I thought that would be helpful. We'll see, and I really just would love you to interrupt me anytime with questions, and we can divert from, I've probably planned way too much, but we can, we don't have to cover it all. We'll just see what you find interesting. But before I start, do you have would you be able to say what you expect to get out of this session? What are you looking for? Something, just anybody, if you want to articulate that for me. What are you hoping for from me?
You did talk about maths is actually everywhere around us, and it will be important, like you say, to capitalize on that fact.
Yes.
When we introduce activities, it becomes very meaningful, very natural,
Yes.
and children just move into it with already the basic understanding.
Yes, and I will. And that's one of the main things I want to talk about, so thank you, I'm glad. Well, I'll just get started, and unfortunately, we don't have a clicker, so I'm the clicker. But this is, Lawrence Malaguchi, as you know, is the Reggio Emilia, one of the early founding thinkers of Reggio, which has influenced a lot of my work. And I like this because he talks about that kids, it's not artificial for kids to work with numbers, quantity, classification, dimensions, forms, measurement, transformation, orientation, conservation, and change, speed and space, because these are all a natural part of their lives. So it's what you're saying, it's they're thinking about all of those things. So they may not have the language or be able to articulate it even verbally, but that's what kids do. And I think this is a nice validation of that idea that sometimes we act so kids don't know anything about mathematics and we have to introduce it to them. The fact is, we have to just sort of figure out how they're thinking already and support their thinking about mathematics. So that's one of the big points of of my approach to mathematics. And so it's important because they are already engaged actively in mathematical learning, and it's important, as I just said, to recognize that and support what occurs spontaneously. So it's not just about lessons, it's also about, I talk with the students, I've just taught the first 2 classes, so it's fresh in my mind. I talk about noticing math as a teacher, being sort of tuning in and obsessing about it, in a sense, sort of looking for it everywhere and seeing it, and then what do you do with that when you see children engaging in spontaneous mathematics? Actually, I want to just also say that generally, and I visited a number of preschools in Singapore, not since, well, I came a year ago, it was the first time since the pandemic, and before the pandemic I did visit quite a few preschools, but I don't pretend to know about your contexts in any great depth, but everywhere I go, I don't see a whole lot of math, intentional or capitalizing on spontaneous math. So, and that's true everywhere in the world. I've worked with schools in Peru quite a bit, and in Japan, and in other places, and it's sort of common. And part of the reason it's common is that our students, as I find out when I teach them, had not very good experiences with math as children. Don't like it particularly, are sort of afraid of it, think they don't understand it very well, and therefore sort of avoid it. So, so you don't see enough going on in classrooms. There could be a lot more, and also I try to change their interest in math and their emotional approach to mathematics, to enjoy it more themselves and see that some of the best things we do are mathematical. So I think that's another important part of teaching about math. And so the students, that's one of the things they'll come to you with, hopefully, having thought about that. But actually, let me go back. But the other thing is that there's a big difference between teaching mathematics to young children from a traditional perspective and from a constructivist perspective. And that's the other thing I see a lot in schools is if there is math, it's often or sometimes, not always, very teacher-directed, rote learning, worksheets, sort of practice of skills. And from a constructivist perspective, that just kills the joy of mathematics. And so we try to think in terms of math curriculum as joyful and exciting, and kids engage in it, and it's something very different than what we see in a lot of classrooms when they do teach math. So I'm just going to really quickly, this isn't a class, but to share with you sort of the big differences between constructivism and a traditional approach. And also I just wanted to say it's not like the world is divided into the 2 types. It's really a continuum. Every classroom has a mix of approaches. Every teacher does some of each. And it's it's sort of a continuum. And so I think it's not like just a critique of traditional approaches. We all do that, but it's to understand sort of the principal differences between the 2, I think is helpful, and can change how we hope our students are doing lessons. So the traditional classroom, and I'm not going to go through all these, but it's about basic skills. So instead of, I'm not going to talk about a comparison yet, but basic skills, fixed curriculum, worksheets are common, not always. Rote memorization and repetition, more teacher-centered, passive learners. Teachers are the source of information. and it's more directive. Assessment is mostly through testing and tasks, and student behavior and products are emphasized. And they mostly work primarily alone and in large group instruction in classroom, in math, in early childhood classrooms from a traditional perspective. Remember, interrupt me if you want to say something or ask a question. I hope you will, because that would make it more fun. In a constructivist classroom, you would see an emphasis on big concepts, on conceptual ideas rather than skills. I talk about big ideas. The Erickson book that you were given some readings, or some of you have already used it, is about big ideas in mathematics, which is a little different from how I talk about big ideas, but it's the same thing, that it's more than topical or subject matter, it's conceptual. It's sort of what underlies it, and we're going to talk about that quite a bit. Student questions and their interests are valued. Probably not worksheets, although I have 2 children. I didn't mention my grandchildren.
Yeah.
Yeah. So my children are all grown up and old, 40 and 44, and they each have a child. My daughter has a boy, my son has a girl. They're 3 and 4 years old. And but when my kids were little, Peter, the oldest one, was probably about 5, and he said, "Mom, how come I don't get to do worksheets at school?" He was in my program. I said, "Why do you want to do worksheets?" He said, "Well, they look like they'd be fun." And I said, "Okay, I'll make you a worksheet," because we didn't use worksheets. So I thought, oh, great. So I made him a worksheet, a typical worksheet about something. He played with it for a little, and then he said, "Mom, this is really boring." So, yes. He got it, but generally constructivists don't use worksheets. It's learner-centered, it's interactive, with exchange, dialogue with students, supporting their construction of knowledge. Curriculum is negotiated. Assessment is primarily through documentation and observation in a constructivist classroom. And the process is valued as well as student behavior. Students work alone and with others collaboratively, and there also are wonderful examples. There's one lovely video of large group constructivist teaching, which is also possible. So it's not like constructivists don't have large groups. Almost every program that I have worked with that is more constructivist has like morning meetings and group discussions about things, and those are an important part of the curriculum too. So it's not that constructivists don't have group work or large group sessions that they use, but they're more, but they're constructivists. So they involve the teacher being more respectful of the students' questions and issues. And just a example that comes to my mind, I was visiting a classroom, I was just observing, and it was a group of 4 and 5-year-olds. And this was in I'm from Portland, Oregon, and it was in Portland. And they were having morning meeting, and the teacher sat down, and she said, I'm really, really upset about something. She said, "I can't find the book I wanted to share with you." It was a book called Snowflake Bentley, which probably in Singapore you don't study snowflakes very much, but we do, and it's a wonderful science book about snowflakes and the science of them. But it's a story about snowflakes. And she said, "I'm just really upset." And she said, "Maybe some of you later could help me try to look for it." And so, but she said, "But I want to know, what should I do when I'm upset?" So she posed this question because the kids looked concerned about her being upset. And they had this wonderful discussion about different ways she could handle her emotions. And I thought that was just such a lovely exchange. So one of the students right away said, well, you could take off work and go to the coast. And she said, great idea, but I don't think I can do that. But it was this, one of the things they talk about from a constructivist perspective is sustained dialogue as opposed to teachers talking. And that was such a nice example of that. So that's the kind of thing you see in a constructivist classroom. Do you have any questions about this piece? I know it's a lot of stuff, but, or anything you wonder about any of these points about?
I think the idea that the constructivist manner also is that the activities or the what we sometimes call lessons, they're not siloed. They have to be, it has to connect to each other, and it's constructing that knowledge, and there has to be that decent amount of time for children to explore so that they're discovering the learning or the concept and not something that would just kind of, regurgitate,
Right, or just being taught in one session.
in one
Yeah.
session.
Yeah, exactly, and this idea of connected thinking is an important part of the whole view of learning for constructivists. Piaget talks about how that one of the definitions of intelligence is the ability to apply what you know to a new situation. So one of the charges we have is to help kids see connections across experiences by having and it's just having a variety of things happening that are somewhat connected. That's sort of the idea of big ideas is that you have things in every discipline relating to patterns or balance or any mathematical concept.
Yeah, and I think for kids, because if they can make sense, if you can connect it to their experiences, then they can better make sense of it. It's not something that's foreign for them. And I think sometimes we stop short of that. Like we teach it or they understand it, but then it doesn't connect to what's happening.
They don't think about it in there.
Yeah.
A good example of that is, and I'm actually going to do it tomorrow in a student workshop, is sink and float. I've seen so many sink and float lessons, science lessons for kids, where it's like this teacher thinks that kids have never played with water and objects. And every kid has played with water and objects. And so it's this sort of assumption that this is a new experience for kids. This is a new idea. But probably not, no matter what it is. There's probably things that they could connect to from their own experiences. And that's a real important part of constructivism, is building on not only their experiences, but also their interests and their ideas. And so that's a really good point. Thank you. Anything else? You hear music because there's a music class next. We'll have to talk really loud so he can hear us. Yeah. Or we could just go over there and have anything else that you want clarification or comment on? Does this make sense so far? So then, to think about math and think about the traditional and constructivist approaches to teaching math is sort of the next step. And I'm going to focus on number as an example. And one of the reasons I think all the concepts are important and good to talk about. But when you ask the students what is math about, they always say number. It's always about counting. It's sort of, they come in thinking that's math, It's not spatial relations and patterns and, all sets and number sense and operations, and it's not any of those things. It's number. So to think about how do we teach number and counting to children as behaviorists versus as a constructivist. So how would a traditional teacher teach number and counting to children.
Road counting?
Row counting? Sure. Let's count. You know, you have a song, or you just practice it a lot in different contexts. Let's count the number of kids that are here, you know, and then you count. And everyone counts out loud, right? And that's a traditional way of teaching it. And one of the points they make in the Erickson book that's really interesting, and was a new way for me to think about it when I first used that book, is they talk about, so that's thinking of number as a noun. 1, 2, 3. That's what we have to learn, are these names for numbers, right? And they say we need to think of number as an adjective. So you're attaching number to a quantity of things. So 3 apples, 4 oranges, you know, so it's used in context of objects, not on its own, right? So just reciting number. How many kids do you know who can recite up to 50 or 100 who don't know anything about number concepts, right? I mean, it's really common. And we always had to deal with parents who thought their kids were so brilliant in math because they could count a high number, but they didn't understand math concepts. So, and the focus, so from a behaviorist perspective, the focus is on learning the skill, as I keep going back to it, sort of being able to do something, to count an array of objects and come up with an answer. And from a constructivist perspective, that's not the point. It's that they start thinking about number in a meaningful way, and that it's used in context of their world, right? So this, and again, I'm telling you all this because this is what we tell our students. So this is what they're coming in with, hopefully, unless they didn't learn it, which is possible. So one of the, wait, did I miss it? So one of the things about number is that's important is we a traditional teacher will directly teach counting or directly teach identifying a particular pattern, right? The names of patterns and how do you do one. But the concepts underlying number or anything cannot be directly taught. Kids have to experience lots of opportunities to use number, or to work with number, or to count, or to have meaningful, as was said earlier, meaningful experiences that involve the necessity to count or the making comparisons, and how do you do that in a more precise way using number. So it has to do with concepts underlying number, and they don't need to be directly taught. If kids are given lots of experiences, and they have already lots of experiences where they have the opportunity to use number, then they don't need to be taught. They'll learn it in the context of real meaningful activities, and it will be different for them because they will have understanding of number rather than just being able to solve a problem or to make an A-B pattern. When in the real world do we make A-B patterns? Well, I mean, sometimes yes, but in isolation from the world to learn about the different pattern names, it's not necessary, and it's not effective. I mean, I think that's the point I want to make is they don't really learn it when they learn to identify the name of it. And we can indirectly teach number by supporting them in their construction of number, by providing those opportunities for children to think about number or anything mathematical. So this applies to not just number, but it applies to measurement, or the same thing with measurement. How many kids, I've seen lots of kids say, oh, I know how to measure, I'll use a ruler, and they'll say, I'm gonna measure this, and they'll put the ruler here and say it's 12 inches. because we use inches in the US. It's 12 inches, but it doesn't have a uniform starting point, right? And so it's not accurate, but the kid thinks they know how to measure with a ruler. So it's the same issue in all of the fundamental math concepts that kids learn about. And so the book, and I really like this book. It's I think it's a very helpful way that our students have learned about a broader range of mathematical concepts than in some programs, and a constructivist approach. But it breaks it down in ways that are, I think, helpful for them to think about planning a lesson or planning an experience. And, you know, I'll talk about this later, but, you know, one of the things we talk about isn't just planning a 30-minute lesson, although it very well could be. It's not that you don't do that, you do that as a teacher. But we also want students to think about, as you were saying, put it in the context of connected experiences, building on previous lessons or experiences, thinking in terms of the environment and everything in daily life that relates to that concept. So it's more than a lesson, but it also could be a lesson. So, you know, I'm not, so that they do a good job, I think, in how they've organized it. And I think you would find it a helpful resource if you're looking at a lesson that relates to any of this. But I just wanted to go through how they organize the book, which I like. So the fundamental math concepts are these, the big concepts. And they're each covered by their own chapter in the book. So sets, number sense, I think those two were sent to you as possible reading. Counting, number operations, you know, addition, subtraction, blah, blah, blah. Pattern, measurement, data analysis, which is a very interesting one. Spatial relations, and shapes. You know, and again, a lot of people don't think of shapes as necessarily mathematical, but they are. You know, it's so each of these is covered in the Erickson book in very interesting ways in terms of what are the concepts for each of these areas. They call them big ideas of mathematics. So what are the big ideas of each of those? And then how are those put into practice in classrooms? They have a lot of examples, a lot of scenarios of stories of experiences kids have or lessons that a teacher develops. And they talk about the sequences for younger kids and older kids. They're primarily focused on preschool, not infant toddler. And that's a whole other area to talk about precursor math skills in infants, with math concepts with infants and toddlers. But they have really some good ideas that will help you think about, that help the students think about it. And again, so the underlying thing is that we want our students to understand what they're teaching, and to teach for understanding based on that. So if you don't know what spatial relations are conceptually, it's hard to teach it in a way that is meaningful to children. So, you know, there's this big issue about how much do our students need to know about content, you know, the science content or math content. And they need to know some. They won't know it all, but they need to know some. And so I think this book is a good framework for looking at what is it that we want students to understand about patterns. Patterns, you didn't have a reading about that, but for example, why do we teach patterns to kids? What's your thought about that? What is the purpose of
How we organize the world.
how we organize the world?
Yeah, and I think think when you said about AB, you get sometimes when we teach it in that manner, they think that only AB or AAB is invented, but actually, like even this, how I want to do an environmental design, how I want to construct something, I need to have some idea of how a pattern might help me to
Right.
make sense of
And what is a pattern?
something that's continuous.
Something that repeats, or, it's repetitious, and it's some kind of consistent repetition. But it's also something that allows kids to predict and extend. So it requires kids to understand sort of the rule underlying the pattern. So AB isn't just a blueprint for making a pattern. It's the rule underlying it, that you go from one to the other and then back to the other one. It's, it could be AB, it could be red, blue, whatever. And too often, a traditional teacher will focus on learning what is an AB pattern, what is an AAB. What's a growing pattern? What's a, whatever other patterns are. And that's not the point. Really, the point is regularity and prediction and estimation. Those are the underlying big ideas of patterns. And so it's rethinking how we what it is that we're teaching when we teach kids about patterns. Because again, a child could learn to tell you what an AB pattern is or to reproduce it for you. But do they understand the underlying rule that you could use to extend it, for example? And can they apply it? Another of the big ideas in patterns is to apply that in different, formats, like in music, or in spatial relations, or in, objects. I mean, there are all kinds of different, so sound, stomping. Music is a great one, but also just in everyday life. Look around, like you were saying, look at the patterns that are here. See, he's making a pattern with that sound. So to think about a big idea, Erickson talks about this, it must meet 3 criteria. So it's not just that here are the 3 things you need to fully understand this fundamental concept, but it's that these ideas, these big ideas, are both coherent and central to mathematics. So all of those big ideas are really important, and they're consistent with children's thinking. Each one of those big fundamental concepts and the big ideas within them are consistent with how kids think about the world. So they may very well be creating patterns and not identify them as a pattern that you are wanting them to learn, right? And also they're ideas, they're concepts that are generative of their future learning. So you build on them. You see the connections across them, you build on them in different contexts. And they become bigger and bigger ideas, right, as children experience the world. So before, I wanted to just quickly look at sets and then talk about some of the other strategies that we use to teach. But do you have any comments or questions? I'm not teaching you as a constructivist, but there's also the question of efficiency, because we could go on and on with this if I were to have us play games. But do you have any comments or questions? Is this making some sense to you? Do you see any of this reflected in the students' work that you had? Or not, maybe not, but this is what I'm hoping people will look for as you work with students and sort of encourage them to think this way. So if they come up with they have a lesson plan about something that seems to you to be pretty traditional and skill-driven, you know. I want this, and unfortunately, a lot of the frameworks that we use, and I think the NEL framework somewhat is about behavioral objectives. But it's, you know, it doesn't have to just be about behavior. It can also be about the underlying understanding. But students might have a lesson that's grounded in a child performing something in a specific way rather than understanding. So I think that's an important distinction.
During curriculum, actually, I encourage the teachers to allow children to apply what they learned. For example, in one lesson, because they were counting in tens, we sent kids to a storeroom full of things and said, you're going to do stock taking. How are you going to do it? It's such a mess. You've got to do it fast. So the children decided to bundle up pencils and then you do complete tests. Things like that helps them to understand that you learn mathematics for a purpose, a real life purpose. Right?
Yeah.
And then, like you were saying, patterns. We got them to create dance,
Yeah.
like in music, we say, this pattern. And we give them the liberty to create a pattern, and then actually the pattern is useful to perform that dance.
Yeah, that's a good
So
example.
it's an application in real life.
Application to real life, that's absolutely important. And using materials that are in real life. I think that's another important.
So, would you say, Christine, that so in my experience, I think the part that confuses the students is when they're trying to figure out what is that big idea. For example, if now we talk about pattern, right? Just now when you asked me and I said it's about trying to organize and make sense of the world, and then my understanding is it's continuous rectangular patterns, and you also share the perspective that it's about being able to predict and make sense of what comes next. And I can resonate with that. So would you say that in that sense, both of it, or the essence of it is there, they don't have to be too caught up of what exactly might it be, which I think is what our students tend to spend so much of time pulling their hairs about, because they're trying to get it right, like what really is there. But if I go back to your previous slide just now, it's really about that it allows that exploration from the children, that it's brought, it generates thinking of that concept from the children. So coming from, for the children. But the teachers first must understand, the students first must understand, as in the teachers must first understand what it is. But there are a few ways of sometimes looking at the big idea. Yeah. Is that
Absolutely.
Okay.
Yeah, and in many ways, you know, and I think this whole idea that keeps coming out of your comments and questions is that why do kids need to learn about patterns? You know, what is that about? And how does it help them make sense of the world? And why is it fascinating to kids? Why is it fascinating to me? You know. And if you start to pay attention to patterns in the world around you, and that's when kids get excited about it, you know, patterns in nature, patterns in the physical environment, patterns among people, between groups of people. I mean, that's when it's fascinating to kids. And that interest and curiosity about it. It's not just, I now know all about patterns. You know, it's like, no. That's not the point. You know, it's that you also want children to experience the joy of thinking about things, you know, that. And I think our students, you're right, they want to know how do I do this right? And what is it that what is my goal? And I think we promote that in a lot of our curriculum and programs and ways of thinking about kids is, what do we want to see them do? You know, all the assessments that we use, a lot are on producing something rather than thinking about something. So yeah, it's tricky. But also, there's so much for us to think about as adults and to learn about and to get excited about. So we can communicate that too to them. You know, that like, you know, I found this great book about patterns in nature, and I want to show you all what I see here. You know, it's like that kind of thing. But then they start talking, oh, I saw that kind of pine cone outside, and look at the pattern on it, you know. So then they start to apply it to other things. And again, the definition of intelligence is applying these things to different contexts, and then trying to think, and what is it and what isn't it? You know, like sometimes someone else, a student or a child will say, well, this is a pattern of one. And that's what? Not going to say that. I'll say, really? How is it a pattern? You know, I mean, is it a pattern? No, it's not a pattern. You have to have repetition to have a pattern of some kind. So, so trying to encourage them to apply the conceptual ideas to what they're trying to figure out too. And what makes that a pattern? Why is this a pattern? Maybe that isn't a pattern, you know. So the big idea, so set, what's a set? This was one of the chapters that was sent to you. So sets, what is a set? It's using attributes to make a collection. So what would be an example of a set that we have here?
Set of tables.
What?
Set of tables.
We have a set of tables? You mean in the whole room?
Have multiple sets of tables. One set.
So this is a set?
Yeah.
This is a set, and that set is of what?
One set of table and chairs.
Sure. Yeah, tables and chairs. This is, and there are a certain number of, and what's the attribute of it?
Number.
Well, the group sitting around the table is a set of people. There's a set of people here, right? What's the attribute? What's the attribute of these tables? I mean, a set doesn't have to be, you don't have to have multiple sets. We could say this is a set. It's a set defined as with attributes of tables that are identical, that are linked together, right? That's a set. And then it's repeating. It's a repeating set. But a set, you know, what do we all have in common? We're all females. What?
Females.
We're all females. We're all brilliant. No, you know, but that's an attribute of us as a group. That defines a set. So that helps us make a collection of people, a collection of tables, you know, whatever we're looking at. We need to define the attribute that means it's a set. And so counting anything requires a set. Something that you count. A set of apples. How many tables are in this room? How many people are in this room? Because that's what we need. And the properties of sets are very connected then to the number system and to other fundamental concepts of mathematics. So sometimes people think of sets and things like matching or sorting people into sets, or sorting tables into different types of tables as not necessarily mathematical, maybe conceptual, maybe not math, but it's very mathematical. It's the basis of a lot of mathematics. And so the big ideas that Erickson identifies are that attributes can be used to sort collections into sets. So we could sort ourselves into a set of people, of women, of brilliant people. The same collection can be sorted in different ways. How could we sort ourselves differently?
who's wearing pants and
Who's wearing pants and who's wearing a skirt? That could be a good way to, another way to sort of. Did you want to add something?
No.
Oh. And the same collection can be sorted in different ways, which I just said. And then you can compare and order those sets. So are there more people with skirts or with pants? You know, that kind of thing. So there are these sort of things about these big ideas that sort of can be more or less complex. So like a really early thing, what would be an early thing you would do with kids around sets, learning about sets or experiencing sets? What would you do?
Okay, like the boys and the girls and what else? Like who wears specs and who wears no specs. They look at more physical, what the kids can
Physical characteristics, things they can see. So food, you know, fruits or other food items are, what's a set? You know, they could have different things, but they have one characteristic. They're all fruit. And then you can get into different attributes of individual fruits, right? So, but there are so many contexts in which we use attributes to talk about things. You know, could somebody go get the paint brushes? And you have long and short ones and fat and thin ones, you know, you have all kinds of them. And a kid might say, well, which ones? So anyway, that's an example of the opportunity to think about sets and some of the big ideas underlying sets. And there could be ways you could challenge, you could say, oh wow, I didn't realize we had so many different kinds of paintbrushes. And a kid might say something like, and by the way, I just made this up, so this might not be a good example, but a kid might say something like, well, I think we have a lot more skinny paintbrushes than fat ones. And another kid would say, I don't think so. I think, you know. So then you have an argument. Now, you're a teacher in that classroom. Yay, that's an opportunity that they're thinking about sets and attributes of sets and making comparisons. What could you do with that? Could you just say, no, I just want someone to bring me all the paintbrushes? That would ignore this wonderful opportunity for math, right? So that, you know, these things, once you start thinking about sets this way, you know, it helps you start to see it, I think, more. Those are just pictures of sets. But so, so this is just a little more about each one. I think I pretty much, when you construct a set, you learn more about sets. You learn more about what does it mean to have a collection of things, and then what are the other different attributes of them. And so resorting things and using a different attribute gives kids that flexibility in thinking about sets and attributes. And, you know, as opposed to just having one rigid idea of sets, of an example of sets, but to use it in many different ways and be thinking about that when you do things. Ordering it. Kids love to make comparisons. So you capitalize on that. Do you think we need more fat paintbrushes? And then that can be the whole start of a problem that kids can get involved in and talk about and argue about, and it's all about math. So, so I want to go into a little bit about, so how do we do this? You know, I mean, I gave you an example already, but I wanted to recommend this website. It's from Stanford. It's called DREAM, and I forget what DREAM stands for. It's some wonderful acronym about math. It's about math learning. And they just have a lovely website with lots of examples, and it's not using Erickson's Big Ideas, but it has, the major math concepts and some videos that are really nice too, and articles. So I recommend this website. Then Erickson also has, the Early Math Collaborative has a website that also has a lot of resources in it. We were just talking about it. I find it very clunky to use, but it does have a lot of good resources that relate to the big ideas. So they talk in the book about these strategic teaching practices, and we've already mentioned some of these, but the first is this idea of mathematizing the world around us. What does that mean? How do we mathematize things? What?
When you see it everywhere.
Well, yes, it's like you start obsessing, and you start talking about it, and you start using mathematical language, and you start thinking mathematically about everything as a teacher. And that helps kids who are already, by the way, thinking very mathematically about the world, do it more, because you're doing it too. And it's really true. Actually, there's a wonderful children's book called The Math Curse. Have any of you seen that book? Do you know that book? Oh,
Curse.
The Math Curse, C-U-R-S-E. And it's about a little boy who becomes obsessed with math. So it's a lovely example of how, actually, I wrote this book on big ideas, and when I was writing the book, each chapter focuses on a different big idea. So, like the big idea of light, using light as a big idea. When I wrote that chapter, I became obsessed and couldn't see or think about anything else except light. Everywhere I went, every book I looked at had examples of light pictures in it, or I'd notice shadows wherever I went, or I'd see I'd hear a song that was about light. Everything was related to light. And I started thinking I was going crazy, but it happened with every chapter I wrote. But that's what you want with mathematics, is you want to be thinking more about math so that you spontaneously use mathematical language. When you're comparing things, you talk about the differences and using the words in different ways. So it just becomes more natural. And it's this sense that when you start thinking about it and noticing it, you will start to notice it more and more and more. And I think that's really important, because if we do that as teachers, children, you're modeling it for them, but you're also building their experiences around that mathematizing. So the other thing is to make it more than just having manipulatives available, which is very important. You want a lot of things in your classroom that kids can count and put in order and do a lot of make comparisons with. But it's more than that, because you want both. You want manipulative, concrete things, pictorial things, and symbolic versions of things. So, you want multiple formats. Not just thinking of math as only in objects. Because, think about it. More or less is not in an object. One is not in an object. That's why it's logico-mathematical. It's all about relationships, not the things. So when you start to think about the math concepts, they're really not about the concrete world. It's about putting things in relationship. So like measurement. I'm short compared to all of you and everyone in the world. I'm tall in a class of 3-year-olds. So it depends on who you're comparing me to. tallness, you know, because I'll have students write a lesson, you know, where they'll say, well, I want the kids to go on a walk outside and look for big things. What does that mean? Big in relation to what? Because bigness isn't in an object. You can't say, well, this is big and this is small, but really, this could be big compared to an ant. You know, I mean, it's all relative. And that's the definition of logical mathematical relationships, is it's all in relation. So the symbolic and pictorial things are helpful too, because that's another realm in which children experience mathematics. So that's important too, and I think we get very hung up on manipulatives. Again, not to minimize that, but it's really important. But again, get mathematics into children's eyes, ears, hands, and feet. So you represent ideas in multiple contexts and formats and modes, and you don't just restrict it to, say, pictures of things and objects. You think, okay, but what about sound? What about, you know, sound? What would be another one? How something looks, how you move, you know, things like that. And then the final strategic thing is to scaffold children to construct their own knowledge. So you're not teaching them these concepts. You're giving them opportunities to construct their own understanding rather than, and they may or may not. But your job is to try to understand how they're thinking about something, and then provide opportunities for them to apply it more broadly or do something else with it, you know, so that you're paying attention to what they're thinking and sort of promoting something. And trying to think of a good example of that. I have an example of that. So the kids in our early childhood center, we had we put paper across the wall for them to draw on. We were doing a lot of things with different ways of drawing, using different kinds of paintbrushes, different kinds of pencils. So we put paper up and we had some materials they could draw with. And then one of the kids said, well, I drew this and I want it to be clear, so can we move this up? So we moved the paper up and put a clean sheet of paper underneath it, right? Because that was a kid's idea to have two different, you know, one was all drawn on and written on, and then one was fresh, so then they wrote. And then one kid missed a day, so it went up like 4 different levels. One kid missed a day and said, but I didn't get a chance to draw up there. And so we said, well, how could you do that? I said, well, I could get a longer pencil. So we attached pencils to dowels, you know, sticks, so he could reach it. And that became a whole different world of extending things to be longer and different lengths of things to draw in different ways. And of course they wanted to draw on the ceiling, which we had to put paper on the ceiling, you know. So you can get carried away with that. But the point is, you are paying attention to what they're trying to do and turning that into an opportunity for them to put that idea into practice. Oh, another one was related. So we set it up so there was paper on the floor, and by then we had dowels with markers on them as part of what they played with. So it was set up so they would sit on the table and draw on the floor with these long markers, right? So what we didn't think about is that with those long dowels, and some of them were pretty long, they could draw on the ceiling, and there was no paper on the ceiling. So when they started to do that, we said, great idea. but we can't draw on the ceiling. What could we do so you could draw on the ceiling? You know, so again, they were extending it, the idea, and we needed a little bit longer dowels to do it because they were trying to jump up and reach it, right? So they helped us make longer dowels. They helped us extend paper up on the ceiling. And it became a whole thing about comparisons and length and measurement and problem solving, you know. So that's scaffolding. You know, I have to say something. When people talk about scaffolding as a teaching strategy, it's a little confusing because what does that mean? What's your definition of scaffolding? Building on extending?
Like, I guess it's also about trying to understand what you know, and then,
So you know what to do with it.
yeah, and then, trying to do that. It's not just building on, and also I think it's not building on in what I think I want you to know, but I think building on the direction of the thinking that I'm on, in that sense.
Well, it's interesting because when I see students talk about scaffolding, they'll say that it's, and actually if you Google it, some of them say, here are the different ways you can scaffold children's experiences, and some of them are direct instruction. Well, I can extend it by telling them, blah, 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 you know, it's direct instruction, it's not acknowledging their thinking, it's imposing, so it's very behaviorist. So scaffolding isn't necessarily constructivist, but this is to construct their own understanding, so it's focusing on it. But I think, I'm telling you this because students use the word scaffolding in, I think, sometimes inappropriate ways in their writing about their activities. They think it's just asking, it could be asking a direct question. They think that's scaffolding. And I'll say, well, yes, you could, that's not really scaffolding. Because scaffolding implies that there's a basis for what's being added on, right? Because that's what a scaffold is. And so, yeah, I need to correct the student. No, I'm kidding. Correct. But I don't know how to get away from that. I think a lot of university teachers are a little vague about what scaffolding is too. So I've been trying to think about that. So somebody mentioned this, mathematics in the world around us. So these are, we already talked about all of these, so I'm not gonna go through these, sorry. So, I'm looking at the clock. And I'm wondering if I should skip through some of this. I think I'm gonna skip through some of this and get to some of the other things. Context for learning mathematics. I think this is really important, and it's come up a couple of times that we think about mathematics. This is what I teach the students this week I taught them, we talked about this. We talk about it happening throughout the day, in almost every part of the day. How is it happening? Throughout their play and across the curriculum. So how is math happening across the day? Where is it happening?
Or when they come in, for example, and then they have to put their shoes in their things, and that's like matching and so many things together. You have to line up so that there's a letter more, and it's all that.
It's sort of endless.
Yeah.
Taking attendance. And so, but if you start to think about what is mathematics, about all of those things just at the very beginning of the day, then you start to think, what could I do to mathematize that, to make it more intentionally mathematical? So a really good way, and we're going to talk about this next week in my class, is attendance. Because a lot of teachers just take attendance. It's like, you know, like I do in my class, I pass around a sheet and they sign it. That's not, I could make that a mathematical activity, but I'm not going to because it takes too much time. But in a preschool class, that could be a really important part of how kids start to learn to do different things with mathematics, because it's a meaningful use of mathematics. And an example that I've seen also relates to using it for a variety of math concepts, and that would be, for example, using a question of the day. This is for attendance, and the question is, are bugs creepy or cool? Or I like vanilla or chocolate? And then they put their name by the one that their answer. And then you talk about, what if we learned about what people think about bugs, or how come nobody likes chocolate, or, you know, that kind of thing. But you they start making comparisons. Interesting, in class, I did, we were talking about data analysis as a fundamental math concept. And I said, okay, how many of you prefer vanilla or chocolate? Which one do you prefer? And the first, I have two sections of the math class. The first group said, I said, how many prefer vanilla? And half the hands went up. How many prefer chocolate? Half the hands went up. I said, okay, this is a case where it's not evident which one is more and which one won. So we'd have to count you. So we counted and found out that more people like chocolate, but it's only by 2. The next class, I was surprised because 2 people put their hands up for vanilla, and everyone else said, or no, 2 people said chocolate, which surprised me. Everyone else said vanilla. And so that when the hands went up, and then everyone's hands went up for chocolate, or vanilla, and then whichever, you didn't have to count. I said, we don't have to count. We do not have to do data analysis. We can do a direct comparison. You know, and so again, thinking of attendance and voting on something for attendance, or many, many other ways. I mean, this is just one little example. That becomes just a rich area for sort of routine math in your classroom. And you don't just do the same, you know, so many classrooms do things like one way of doing attendance that itself might be mathematical, but they just do the same thing every day. You change it up, you do so many different things. Same with the worst one is calendar time. Do people do calendar time here now still? How do they do it?
Not just calendar, I think they will say what's the date, what was it yesterday, what is it today, yesterday was Monday, Tuesday, and then after, some centers, not all centers will do calendar, but some might bring it out, and then the kids will cross up yesterday, and then they'll see this is the date, and then,
Yeah.
and then some centers I've seen as well, they actually, especially if it's, so this one had a lot more foreign children, and so they had just come back from the holidays, and then they'll talk about, oh, so and so left on this day, then they put an aeroplane with the child's face, and then he or she's coming back on this date, and then they'll put it, so they'll look forward to the friend coming back.
I see, yeah.
on
So
that
they're markers for
markers, and yeah, so that's a bit more relatable for what they don't know. I mean, so there are different variations.
Yes,
Some do it
yes.
more complex, some just write the date and
Yeah, and very often it's you know, when I ask teachers, why are you doing it? What do you want them to learn? They say, well, they're learning about numbers, they're learning about order, they're learning about yesterday and tomorrow. Yeah, okay, but if they do it every single day, why are you doing it every single day? And it takes up a chunk of time, right? And it's a waste of time. And there's a wonderful article, if you're interested, we can share, calendar. And not that you can't use a calendar in some good ways, you know, I mean, but it's that when you see how it's used in a classroom, it's often redundant and never changing. Same with attendance or anything that is used in a classroom for math. Because people will say math is what calendar is about often, because it involves number. And like I said, a lot of people define math as number, anything involving numbers. So when we talk about materials in a classroom, which I was going to talk about if I get to it, when you ask people what materials do you have in your classroom that's related to math, they'll usually say things related to that have numerals on them, right? Like games that have numbers on them, cards, you know, whatever. And materials relating to math are much more than things with numbers on them. You know, there are many more ways of doing things than that. So it's a
Christine, sorry, just extending on that, right? Would you say then it would be, if you happen to introduce the calendar, that it doesn't become something that's every day, maybe for a certain period, and then after that it becomes just part of the classroom. Maybe on different days, different kids can be the ones to just go and mark it out, as opposed to making it part of daily
time consuming.
time.
Yeah, I mean, you could do that, and again, you'd want to think about why do you need that visibly up all the time? Do you? Why do you? How do you use it because it's there? You know, how do you refer to it? I mean, again, it's not that there's anything wrong with it, it's what you do with it. And does it just become a repetitious task without
So
any
more the
meaning?
rationale behind it, and if they have a good rationale,
Yeah.
and it's something that, for example, if the kids use it as a reference, like maybe they're trying to learn about the concept of time, let's say, or understand or refer to it if they're writing. Because I know in K1 and K2, they do get the kids to write the date. And then sometimes they ask the kids to, instead of just copying what's written by the teacher on the board, they'll say, you know, have a look at the calendar
Yeah,
and then figure out, yeah, what's. If it has that, then it's, as long as it's just not a time wasting thing, that's what you're saying.
Okay, but, and there's nothing wrong with that, I'm not being critical of that. I would say that identifying the date and how to write a date is not mathematics.
Oh yeah, as in not,
Yeah.
as in
Because-
it's just part of their, what their daily practice is. That-
Yes,
Yeah.
yeah, that's
But
fine.
you can't term, you're saying it shouldn't be termed as that's their thing to math.
Right, because it's like number sense. One of the big ideas is that numbers can be used in mathematical ways, and they can also be used in non-mathematical ways, like platform one. Platform one is really not related to math at all. Because, you know, it wouldn't necessarily, it could be not even visibly related to the other platforms, right? So we use one as a label, we use number as a label of things, you know. And so, calendar is a lot like that. We're not really looking at it as mathematically often. I mean, one thing I've seen people do with keeping track of days and time is to do a number line or a string with beads on it, and then you make comparisons of size, and you know, I mean, there are different ways to think about it. It doesn't have to necessarily do with number. It can have to do with comparison and order and that. So you know, it's just to think carefully about the things we do in the classroom that we're thinking are mathematically oriented, because sometimes they aren't, sometimes they're not. But the opportunities throughout the day are huge. I mean, we could go, we won't, but we could go all through the day and find things that we could do all the time. And when teachers start doing that, and they start thinking more planfully about, well, how can I make the choice of which fruit you eat more of an experience around sex or comparisons or, whatever, number even. And so it's sort of a little overwhelming, but in every, like distributing things, Constance Camille talks a lot about everyday math, and I'm gonna see, this is what she says. So things, handing out things, that you don't do it, you have kids do it, because then it's an experience of deciding how many you need for a table, and then picking them up, and you have to count them. There's 6 kids, I need 6 spoons. So it becomes a mathematical thing, and there are lots of opportunities for things like that throughout the day. Cleanup is huge potential for math. Throughout children's play, so in all, we won't go into it because I think we're ending at 4:30. Is that correct? Okay. So I'm going to just go through this real quickly, but I can share with you my slides too if you want. I'm not going to do that, but there are examples we can think of how is mathematics involved in every kind of play. We actually once did when I was looking at science and math in the classroom in materials, and we did an observational study of where in the classroom was math and science going on spontaneously. And we looked at all the different parts of the classroom. And where do you think that most of it was happening? Dramatic play? Is that what you said? Yes. Dramatic play or symbolic play. In the dramatic play area, that's where there was the most science and math going on. And that sort of surprised us, because we thought it'd be in the block area, frankly. I thought it'd be more in the block area. It was a lot in the block area, but it was more in the symbolic play or dramatic play area. And across the curriculum, we've already talked a little bit about that, but in projects and just making a point of always having the remarkable number of amazing children's books available that relate to mathematics, some of which don't even use number. They might involve something else, some other concept. And these are just 2 of the places in the Erickson book where they talk of examples of activities for exploring sets and number. And it's just so that if you look at those references, you'll see the kinds of things that you can then sort of generate. But many of those activities might involve a game that the teacher introduces or materials that are available for children. It's not necessarily a lesson, but it could be. Some of them are. So I think I'm going to end it on this. Let's see if you have any questions. I'm sorry we didn't have more discussion, but we had some good discussion. Do you have any questions? Comments? Was this helpful for you in thinking about what students are doing? I just think it's important to understand what they're hopefully coming with, or at least some of the questions they might have. I'm not saying they internalize everything we teach them, because they don't, but still, this is what we're sort of aiming for in math for the kids, for the students now. So, well, thank you guys. Thank you. Nice to see you.